Good afternoon, everyone. I'm Tatiana, this is Amanda, she's my daughter. And the first thing I wanted to say is to thank the organization. Sometimes people speak about diversity and everything, and I think very few things speak as much as organizations and conferences who welcome children without questions. And especially for single parents like me, this makes a difference in joining conferences or not. So thank you very, very much to the organizers. Some examples of conferences in the past where Amanda was able to join since she was 5 months old and went to the stage usually with me. Sometimes she has her lines. Today, I don't think she will have many though. So how many people in the audience are familiar with Airflow? Brilliant, that's very good. Okay, so I got introduced to Airflow a few years ago. So I was working for the BBC by the time, where I was hired as a data engineer. Before that, I had only software engineer, computer engineer titles, and I was still trying to figure out how to be a data engineer. I think I didn't figure out until now, but by the time we had a goal. So the goal we had was, we have this third-party recommendation engine, and our team had to replace that by some technology, hopefully open source, within the BBC. So we wanted to replace that technology by something else. So the BBC wouldn't be relying on a black box that was proprietary. And one of the applications that was powered by this recommendation engine was BBC Sounds. By the time, we wanted to build some sort of pipeline. So the two data streams we had, one was user activity, the other was actually program metadata that wasn't actually a stream. And then we had a team of data scientists who really wanted to use factorization machines by the time, so we're speaking about 5 years ago. And then by the time using the technology that they really wanted to use, we couldn't figure out a way of having the responses in less than, let's say, 100 milliseconds for the millions of users we had in BBC Sounds. So we ended up doing it in 2 stages where we would train the model, we would have some offline predictions, and then we would refresh those predictions from time to time. So we had a sort of batch processing strategy where we would have processing the user activity and content metadata from time to time. We would train the model, and then we would calculate predictions. By the time this factorization machine algorithm we built had very good click rates and things, so we managed to get an uplift by 59% overall. And especially with the age group we were focused, the BBC has been very focused on younger audiences. We had an increase of double the engagement of users. And that, of course, we didn't want just to maximize the click-through. We had some editorial team members who praised diversity and many other aspects. So there were a few things that we had to have on top of what the algorithm gave us. By the time, as now, there were many technologies for us to choose from. We were the first team in the BBC using Google Cloud, who had to make a product in production using Google Cloud. And we analyzed by the time data flow using Apache Beam, and we considered using then also Composer, Apache Airflow. And I was very inclined in using some stack that would be open source, because the same way the BBC had AWS and they had GCP, there could be other things. We could move again to be on-prem. So there were many possibilities, and the flexibility to have an open source platform really was appealing for me. And to have a Composer that was a managed service meant I didn't have to manage Airflow, which was a relief, because there were many workers, database, many components that usually you don't want to spend time building, especially if you have a very tiny team. At some point, I was one engineer who was doing all the part of data engineering, DevOps, and software engineering. Yes, data engineering. And then we had 3 data scientists who were learning to write more production code by the time. And now 2 of them are machine learning engineers, and I'm really proud of them. So why did we choose Airflow? First, Python was the main language in the team. We wanted something open source. We wanted something highly flexible. Let's say we wanted to change from Apache being a particular part and then use PySpark using Dataproc. We could, if we wanted to switch databases and things. The community was extremely active. I was interacting with people during the pandemic, outside of the pandemic, and the committers of the project were extremely responsive to questions and problems. And you can host yourself, or you can use GCP, AWS, Azure, or even Astronomer. That's the company I work for. So you have many managed options, so you're not locked in. And the fact that Apache Foundation is the institution behind it, I think gives us some guarantees. So we know that since there isn't a single company, many companies release open source projects, but then they're the ones who are committing 99% of the things. And then they can change license at any point, as we've seen in the past with Terraform, with Elastic, more recently with dbt core, that actually became dbt Fusion to some extent. So when we have open source projects that have one main player, we are sort of relying on them. And with the Apache Foundation, we have some guarantees there. Since then, we released those recommendation providers and everything. And Astronomer invited me to actually work for them, building open source full-time. So they said, don't you want to join the community on the other side? So not to be a user, but actually contributing to building this ecosystem. And by the time I didn't realize how big was Airflow. So in PyP, we have somewhere around 20 to 25 million monthly downloads. There are over 3,000 contributors. GitHub stars I don't trust so much. There are lots of messages in the Slack community. And Astronomer, by the time I also didn't realize, which is responsible for all the Apache Airflow core project releases, contributed to more or less half the code base, has several members in the committee responsible, and students and everything who are taught. So I thought, well, I love the BBC, but perhaps I should give a try and see how it is the other side of being part of this bigger community. I also didn't realize until recently that there were almost 100 providers that are actually part of the Apache Airflow repo that allow you to integrate to Google, Amazon, and many other services, Apache services like Iceberg and other things. And when I joined Astronomer, they actually gave me the challenge, can we improve a bit the experience of DAG authors in how they interact with Airflow, how we integrate Airflow to other technologies. So this is a syntax from Airflow 2. We had the 3 release not long ago. With the 3 version, we wouldn't need to be declaring this DAG explicitly. Each of these tasks could now be assets, and then you can define the schedule per asset. So it's becoming more DAG-sterly look like, and it has many other features such as versioning and everything. But this is just an example DAG, how it looks like, the age of the workflow for those who are not familiar. We define a workflow, you can set a schedule, and then you can define tasks. In this case, I'm just invoking some Python functions that were previously defined. But you could actually do almost anything. You can connect to Slack, you can connect to databases, you can connect to transformation, you can delegate to Kubernetes. I think there are very few limitations. The one thing to keep in mind is that Airflow is still a sort of orchestration platform. So for heavy processing from a CPU perspective, running things directly in the worker node may not be the best choice depending on your infrastructure. There are people who tune to have different node pools and things, so that's fine. But some people sometimes have expectations. I will have a high concurrency and then CPU intensive tasks, and then things may not scale as well. This is another example of an Airflow DAG using a tool that I also developed at Astronomer called Cosmos, which allows to go from dbt projects into Airflow DAGs. So it's using dbt core, We will soon release a PR to support DBT Fusion as well. And basically the idea is, could we give a simple interface? So we created an abstraction to the DAG class, the workflow class, to be able to simplify, and people can just give the path to a DBT project, and then you can see all those tasks, retry, see failures, see the SQL associated to each transformation. On the Ray land, what started, how many people here are familiar with Ray? Okay, so less. I would say that there were around 90% of people familiar with Airflow, and perhaps around 5% familiar with Ray. I'm not that familiar with Ray either. So I learned it from some of our customers. Apple uses it quite intensively. They already spoken publicly about this. Several other companies use. And the problem it aims to solve is to have a unified, large-scale data processing and machine learning platform that allows people to sort of abstract from the underlying infrastructure and at the same time scale. It has CPU and GPU support. It's created by a company called Anyscale, and it's maintained by them. It is an open source project, and anyone can download it, you can use it against different managed services. Again, you can use it in different hosts in AWS, in GCP. You can define different sets of infrastructures. You can give how you would like to be the cluster for this tool, because it will basically parallelize the job across multiple nodes, and you can specify how those nodes should look like. So it's extremely flexible. And then they basically build Ray Core, which is an abstraction on top of these layers. And then there are several libraries that integrate to other very popular machine learning tools in the market. So they offer things related to training, tuning, serving, data processing, and all that is available. And you can integrate to PyTorch, to XGBoost, MLflow, and many, many other tools. So here there are some tiny examples of how, for instance, you could read some data source and then test that. There's another example using XGBoost trainer, how the code would look like. So they try to offer this sort of unified interface, as unified as you could, and then simplify how those things will actually be run. In a way, people could potentially be running very tasks that take a long time, much faster, assuming they can be parallelized across multiple workers. So it's extremely powerful. And then you can always run this Ray commands locally. You can run from VMs, you can run from containers. You can manually manage the clusters where those things run. But the managed service for Ray would be to use Anyscale, which is a proprietary platform. So if you wanted to have jobs that are run from times to times, you would probably have to leverage Anyscale platform. So this is just another example of Ray, how it could look like. Let's say you had multiple tasks in Spark that process files, they output into Parquet files. And then you could have Ray hedging worker nodes, fetching that data, processing, passing them to some model, which could then be trained. There are lots and lots of resources on Ray, and my knowledge is relatively superficial. So what we did in Astronomer was, several customers were using Ray, and they said, how can we best leverage Ray in the context of Airflow? So we're happy with Airflow. We have a few tasks using different services, and we would like to be able to trigger our Ray jobs from Airflow. And at the moment, we don't want to pay for a commercial service for that, and we would like to leverage Ray. How could we design this interface in a way we could integrate these two technologies? So that's when we created this project, asked to provide Ray. It's Apache 2 licensed as well. There is even a demo in the Astronomer website, but you would have to type your details there if you want to play with it. And then basically the features we offer in this integration are, you can create and delete Ray clusters. So let's say you have a Kubernetes cluster where you would like to be running those things. You can have Airflow managing those clusters for you, given your configuration. We also support to actually, for you to specify that configuration dynamically. So you don't need necessarily to hard code in a file. You could have it calculated in one DAG and then the next DAG to use that configuration and then trigger the jobs. We also support for end users to be able to actually trigger those Ray jobs. It is possible to track the progress of those tasks in the Airflow UI. So we are consuming the output of the command so you can check those things out. You can connect Ray with non-Ray things in the same DAG. You can leverage Airflow, now assets, previously called data sets, to do event scheduling based on other data and things. And it's open source, so it's Apache too. So for those familiar with Ray, some examples of things that, or Airflow, you could be leveraging Ray to do scalable ETL, considering you would like to leverage some map reduce. You could be leveraging to train models using Ray train. You could also use inference using Ray serve. This wouldn't necessarily, you wouldn't usually be using Ray serve within Airflow, but those are possibilities. This is how the code looks like. My plan is to do a live demo, but just in case I thought it would be useful to be showing this. So by your left, you can see a pipeline. This Ray spec is actually how we expect the cluster to be configured to run that job. Then we specify what we would like to be installed in the Ray environment, and then in which directory or the scripts we will be referencing, so where the Ray pipelines written down. And then you can leverage traditional Airflow syntax by using operators such as submit Ray job, where you would have a connection, so we specified a custom connection for Ray, and then you can specify the command. This command will be then considering the path you gave and other things installed based on the dependencies here. And then you can specify, override some configurations regarding CPU. You could export things to XCOM. And then there is another traditional operator to set up the Ray cluster and another one to delete. This is the sort of old school syntax for Airflow operators. We also offer a newer interface using task flow, where you actually leverage Python decorators to then specify. And then all this logic of setting up and deleting the cluster is sort of internally handled by this magic decorator. So you give the information, and then we will be handling to create the cluster if needed or not. So I think I will do the demo now. Let's see. We are good in time, so let me see here. Hopefully. So how is the font size? Is it some thumbs up? Okay. So here, I spawn up Kind, just because I want to continue on the open source stack. So Kind allows us to have a Kubernetes cluster locally. And I'm using K9S to see it with this nice interface. On the side here, I'm simply running Airflow standalone here. So you can see my Airflow standalone running. And then you can see that at the moment, what we have are some Kubernetes-specific pods. And then I also have this show MetaLB just to expose the load balancer to my host, just due to how Docker works in macOS. So now I will copy this very secure password. So in case we want to log into Airflow UI, let's go here. We will open Airflow. So you can see we have a few DAGs in Airflow. I will first show the setup and tear down. And I just found out we are having some bug on the tear down. You can see there was lots of issues not long ago. So the way this DAG looks like, we have a setup cluster. We then have a submit Ray job, and then we delete the cluster, which is not currently working. The way the DAG looks like, we instantiate the operator, we submit the job, and then we delete the cluster. And then here we specify that the first task is a setup and the other is a tear down. So I would trigger this. So what we would be seeing ideally by this time is we will eventually, if things are running as expected, we will see here the creation of the Ray, cube Ray operator, which is needed when you want to set up a cluster. You can have one operator for multiple Ray clusters if you would like. And then you can see we also install the head and worker nodes, which will then be actually executing the job. All these pods are running. If the demo was 100% successful, we would be seeing these things tear down as well, if there wasn't this bug I reported in this last version. So we can see here, it is setting up. We can see things here. It succeeded. The success of that thing is actually if the service was successful. So we check if the load balancer is up. So we can do namespace, right? And then we can see, oh no, something went wrong. Yes, there is something not very happy here. So let's see, get SCV. That's what happens with live demos. Namespace Ray. The thing seems to be up though. It even had an IP assigned. So let's see. Here, Airflow thinks things were successful. So we can check in the logs. We can see the Ray cluster was created. The load balancer was set. We have IPs assigned, which Airflow can assess. And things seem to have been successful. On the job submission, we can see that if the cluster wasn't set up, we would be setting it up. We identify what is the dashboard URL for the Ray cluster. So Ray has this interface where we can see the jobs. You can see the job we just submitted here. And then we can get the details about it. So we expose that as well. We then actually submit the job. In this case, it was just some very simple example, like saying hello world. But you can see the job was actually submitted. We wait for the job to be completed, giving some information. So that it was successful. And then here, it is a bug that we need to improve. So another example, so I will now delete the cluster. So what I'm doing here is, no, not that one. Okay, cube, ctl, delete, namespace, right? We're deleting this thing, so if we check now, here, we can see that our Ray cluster is being deleted. The pods are being terminated. And then we can trigger another Ray task. This one is using the other syntax I showed that leverages the decorator interface. So here we have a task that generates data. This could be retrieved from anywhere, really, from an S3 bucket, from some database, anywhere. You could even have it as a parameter of your UI if you would like to trigger this manually. And then you have the actual Ray job. In this case, it's just calculating the square, but you could have more sophisticated pipeline. So let's confirm there is nothing more in our cluster, so I will trigger this pipeline, and then hopefully it will work as well. Let's see, so the task generation was successful, but that's not really leveraging Ray, it's just this task. So That's the easy bit, and then we will eventually see if this is successful. Some potential usages for this integration. So you could build a continuous data update flow. So you could have some particular DAGs where you ingest and transform data, and then those DAGs could be triggering your array DAGs. So things are integrated, you have separate workflows, so they're easy to manage, easier to test, but then one depends on the other using data sets or assets. You can continuously have models being built using some schedule. And you can also integrate to LLM models if you're doing that. And we would love more feedback from the community on, is this a good approach? Does the interface of operators we're proposing make sense? For those who use Ray, would you rather other types of operators that would be more useful? So that's just a slide that shouldn't be here. From an adoption perspective, the project is still in early stages, which means we only have around 1,000 downloads per day, which means, and we recently grew in adoption, but it's a project that has less than 20,000 downloads per month. Compared, for instance, to Cosmos, the project we developed that interfaces with dbt Core, that has around 16 million downloads per month. So this is in much earlier stages, so we do expect feedback and contributions and bug reports. The demo was already done. For those who may be interested, it's in GitHub, so Astronomer Astro provide array. The documentation is here. And there's even a channel in the Apache Airflow Slack namespace called Airflow Ray. So people can discuss either people using this provider or not using this provider, just a space for people dealing with the integration of these two technologies. And recently, there was a very interesting discussion in the Airflow dev mailing list, where someone said, I'm trying to work on this sort of integration. Would the Apache Airflow accept this integration if I were to donate? Because you already have 100 integrations. Why not one more? Why would you accept? And it was quite interesting because the reality is people who are maintaining Apache Airflow, I think we're finally realizing we can't just be responsible for 100 providers, 100 integrations. There is no way Apache could be accountable and have knowledge in all those things. So many of those tools are extremely complex. Ray is one of them. And then to troubleshoot, to run proper integration tests and validate can be a challenge. So there was this discussion, and it was closed with Ash, who's one of the committers who's based in London, saying that he believes this sort of things should be maintained by any scale or someone else, but that we should not have it as part of the Apache Airflow repo. That said, the project remains in the Astronomer repo for now. If anyone would be very excited, we would love to have more contributors, other committers, and to share the evolution of this provider.
Thank you. Any questions?
Thank you very much.